Hey everyone, welcome back to the Ben and Danny show. Last week we looked at collision detection and collecting diamonds. But Ben, what are we doing this week?
Well, that's a good question. So we're going to have a look at, firstly, we put enemies in last time, didn't we?
Yeah, all right, I forgot that part.
But however, we put in enemies for the collision detection stuff. But one part of that was that they just looked like white boxes, if you remember. They were just white boxes on the screen, and they didn't look very much like enemies. So I suppose the first thing we need to sort out is that and make sure they actually look like enemies.
We needed to add the white boxes in them before we made them look like enemies. We needed to get the development side down of it, that collision, the development side, and then basically we're making it look pretty. We're giving the game like its kind of final polish.
Yeah, exactly. This kind of pattern of making something quite rough and then later on polishing it so it actually looks like a finished product. That's one thing you see usually in making games, at least in my experience. But we're gonna look at actually making the enemies look like our enemies. We're going to do some very, very basic AI. I wouldn't even call it AI. We're basically going to make the enemies move back and forth. And probably the biggest part of this today is animation. So we're going to have a look at how to just play an infinite animation on a character, but then also look at the more complicated animation stuff like changing animation states. So the player can stand, have an idle stance, a walking stance, all this kind of stuff. I think that's really everything that we're going to look at today. I think
so. It's going to be a good one.
Yeah, I see Phil is in the chat. It's always good to see Phil.
It's Benny. I did that. I keep Benny doing that. I keep combining like our name basically.
Yeah, the Benny show.
The Benny show. We should just rename it to just the Benny show.
Yeah. Okay. It's good Phil's here. It's always good to see Phil. Good egg. But that's what we're gonna look at really. We're gonna Benny and Dan show. Yeah.
Benny and Dan.
That's what we should call it now. The Benny and Dan show.
Just completely different.
So that's what we're gonna have a look at. I think I think that will largely be the content of today. We might go fast through some parts and slow through other parts. If we do have time, we'll eventually touch on canvases. However, I don't think that will be the case because there's a lot to get through.
Yeah.
I think that's really it. That's what we're going to look at today. So I guess show my screen and
let's get to it.
Get started. Yeah. So first thing, as I said, it was this idea of our enemies just being boxes in a level, and as you can see, these do not look like enemies. Maybe in some.
They could be in like a shape game that I feel like we need to create now, Ben.
Yeah, this is like a
the Ben and Danny shape game. Really. Shape show.
Yeah, it's just 10 episodes of us discussing different shapes. This is a rectangle, and this is a triangle. It's got 3 sides. Yeah. Well, it is, I guess. We could. That's what we're going to look at is changing these white boxes to actually look like enemies. Because at the moment, as you can see, they do act as enemies. Like when we jump into them, as you can probably see, it does start doing stuff when Unity eventually loads. Here we go. If I jump into this box, I respawn. But we want to make them look better. So what we're going to do really is, at the moment, these are just boxes. So we want to kind of take these out and make an enemy prefab. And this is why we showed you. This is why we showed you how to do prefabs, because it comes in quite important. But this kind of stuff of having like a white box and then changing it to an enemy later, getting the basics down, we usually do that kind of stuff. So let's go to prefabs, okay? Or actually, no, let's not do prefabs. Let's go to sprites, because we'll make a prefab quite easily, and we'll pick out some kind of. So we have loads of sprites here. We have pig hiding in the box animation. So I don't know. There's a box there. I think our character is the pig. I don't think. I really don't. Yeah, it's that. Right. I don't think. I think that's meant to be the enemy.
But... No, but it's so cute though.
I know. So
I don't want to be the pig.
Yeah, maybe in this game we can kind of flip it round. So we are the pig and the enemy is the human for some reason. So with that in mind, we have the kind of human character here. We have the different animations. So we have attack. If I double click on this, it's opened up on my other screen. But as you can see, this is the attack sprite. And as you can see, there's 3 separate things here. There's the, I don't know what you call that, like the swoosh, and then the kind of after swoosh.
After swoosh, yeah, it's kind of like
yeah,
the strike, and then it's like,
and then back
up again, and then normal, yeah.
So that's one, but the one we're going to use is the run animation, because we want to. The end goal of this is to just have a little enemy running back and forth, going left and then going right, and just kind of going back and forth, so we can have at least something resembling a game. So here is a run cycle. So if we swap the sprite from this to this one to this one to this one, very fast, you would see this little character running around. So that's what we'll do first, and then we'll get onto actually putting them in as enemies. So I guess what we'll do then is I guess just get this character in. So the first thing we got to do is turn this into a sprite. You're probably thinking, oh god, do we do that a lot? And unfortunately, yeah, we do. It's quite a common thing we have to do. So we have to go over here. So you click on the run thingamajig. We've got the word texture, asset, whatever, the image. You click on it here, and you have the import settings up here. So I think we're gonna like make the appearance of this look like an enemy, but I suppose another part of that is how do we actually make them look like enemies? Well, we could just change the sprite like this, but we could do all kinds of stuff. Maybe a good start is to make them move, and this is the idea of us moving the enemies left and right, is because it gives a little bit of life to the game. Things usually moving in the environment indicate kind of interactive objects and obstacles. It's not just part of the background. And one of the most basic forms of movement is just to move stuff left and right. It's not really AI, but it's just moving stuff left and right. And if we can have an enemy just moving left and right again, we can do some interesting stuff. So yeah, I mean, like I said, the other thing we can do is just actually make it look like an enemy and not a box.
Yeah, it's just kind of, as you said, making it kind of more interactive and more looks like it, and it's alive within the scene. It's not so complex that needs a whole load of coding and a whole load of settings to be changed. It's just a little simple thing that just makes the scene look a little bit better.
Yeah, exactly. I mean, we're not going for AAA game here. It's just to kind of show you the basics, obviously, and probably, like I said, the most basic form of movement in a character is just move left or right. We could start doing some interesting stuff like making them jump up platforms, but we won't really get into that. Instead, we're just going to make them move left or right. But first, we've got to actually make this enemy appear in the game. So I suppose let's do that. So you turn the texture type here, as we did before, to sprite. We're going to select multiple because there are multiple sprites in this. I'm going to set this to 32 like we did before. Set this to point, no filter, because we have pixelated graphics, right?
Mm-hmm.
And we want to make sure that these are not.
Well, it's basically we want them to be kind of. We want them to look like pixels. We don't want them to look all kind of fuzzy and kind of blurry. We want that pixelated effect and that clear kind of definition.
Yeah, so it's kind of due to the game. Usually with Unity, you put an asset like a texture into the folder, and you're like, I don't really care that much about the texture. Just put it on the screen and Unity does the rest. But in this case, because we want quite pixelated graphics, when we scale these up, we want to tell Unity, actually, I don't want them to be blurry. I want them to be pixelated. So Unity can go, oh, okay, I'll do that instead. And that's kind of what we're doing here. So I'm just going to turn off compression as well. So now we have everything set up. I'm going to click apply. And as you can see, it's turned the background to a different color. And we go to our sprite editor. Okay, we need to, as you can see, there's many different images here of this character, and we need to chop them up. And we've done this before. We just go up here to the little slice button, and we go by cell size. Now, looking at the name of this up here, it says 78 by 58. So what we need to do is just put in 78 by 58 and click slice. And now, as you can see, we have many different sprites here. So these are actually separate sprites, just like we did before, really. So this is a little animation of our character. So I'm just going to click apply here and close this down. And now we have an enemy in the a little enemy texture, right? So I'll try drag this in and see what happens. I don't think that moved in. That's okay.
Did it not move in, or is it in like the back? Oh no, okay, it just didn't move
in. So here we have a a little character, I guess, and we can change this. We can make it move around and all that kind of stuff.
It looks so good in the scene. I just love this like asset pack.
Yeah, it's so cool, isn't it? So the first thing I'm going to do before I forget is to change this to an enemy. I always have a habit of forgetting this, so we're just going to change
add tags. Yeah.
So remember tags last time, so we're making sure that this is, whenever we see an object that we're going to collide with, we know that this thing is an enemy. So that's what we're doing here. We could add a collider. I guess maybe let's do that now. So we're going to add a collider. Basically, everything that's on this box. So we have a collider 2D. What else do we have? Well, I think that's pretty much it, really. We just have a box collider. We could do very much the same thing here. So we could just make a little box collider and make sure it's the 2D one, right?
It's important.
Yeah, 3D box collider and your 2D thing. So I'm just gonna move this collider. So I'm gonna put this here, like this. Maybe let's put the collider maybe about there, I guess, and put this up the top. So
do you not want to include the little hammer?
We could do, yeah. I mean, it really comes down to kind of, I don't know, like if you jump and hit the hammer.
Yeah, that is true.
But to be fair, let's do that because it probably makes more sense. So now we have if anybody touches inside of this region, it is going to flag up. Oh, you've collided with this enemy or whatever. So this is just the hitbox. It's the hitbox for the character. So now we have a little character, and we can make a prefab out of this. So we can go here. We've got character. We've got diamond. We could call this enemy, and we could drag it in here. And now we have an enemy prefab, right? We can do stuff with this. Now I'm just going to take these two out, okay? But let's test this now. Hopefully, when I jump into this enemy, I will respawn. I'll like appear back up here. So hopefully, if everything goes well, yeah, it works fine. This is because the enemy has a collider and it has this tag enemy. Remember that script we made last time where all we're doing is we're saying, if you've collided with something, then check if the tag is enemy. If the tag is enemy, then respawn. That's basically what we're doing.
Yeah, that's what we did last week, wasn't it?
Yeah, and that's what we're doing here. So I suppose the next thing is we could either look at how to animate this character, or we can make it move left and right. I'm not sure which way to go, to be fair. I keep saying this, but this is very unscripted.
Should we do the movement first? Because then you can see how that works, and then you add the animation in, which is, as we said, the final touches as like a polishing part of it. So movement first.
Yeah. So okay, so we need to make this enemy just move left and right. Okay, so what we're going to do, we're going to make a new script. Okay, so right click here, create C# script. And let's type in enemy we go. So let's double click that and open up Visual Studio, which takes a million years to load for some reason.
Yeah, I don't understand why.
Phil says it's cheating, Danny. You should have to make your own art as well.
Well, if it's available to everyone, it's not cheating.
Yeah. But the thing is I have tried my hand at making my own art, and I am terrible.
I made my own art recently.
Yeah.
I mean, it wasn't half bad, but it's not like it was very simple.
Yeah. So what we need to do is essentially, do you remember the stuff we did with the diamond where so this enemy movement script is just going to move left and right continuously. The diamond stuff, if you remember right, let me show you this script that we did. All this is it's the current position of the diamond, okay, equals the original position when we loaded the game, plus up times by. So we're just making it go up and down. That's all we're doing. Now, if you think about this, the enemy movement script is almost exactly the same.
Left, right.
But we're moving left and right. So we, maybe with a bit of different movement there, but it's essentially the same thing, really. So that's what we're going to do. So there's many ways to do this. I'll show you a little function called mathf.pingpong, which is a really useful little tool. But you can do this manually as well. You can do it like original position plus left or whatever. But we'll get into it. So
if we're using ping pong, what's the difference? Well, mathf.pingpong. What's the difference between ping pong and how? Basically, how is it different to .sign? Like what is the difference in that kind of aspect?
Yeah, so it's a good question because this confused me for honestly like a while.
There's just so many maths functions.
Ping pong, I thought that's a strange little function and it sounds strange. And I thought there's no use for ping pong. I'll just use sine. They are two very similar functions. So a sine wave, mathf.sin, will kind of smoothly go up and smoothly go down. So if you ever watch it kind of goes like that. It goes quite smoothly. Whereas ping pong, it's very sort of it's not a smooth movement. It's just kind of linear. It's just like that basically, going up and down at a constant rate. Whereas sine wave has a bit of easing in there as well. So
why would we use ping pong? I think because in my mind, the .sign is like, oh, you hear the word smooth and like, shouldn't that be better? Why would we use ping pong instead?
Yeah, so if you use sine, so you can use mathf.sin, you can use the sine wave function. That's perfectly fine. So you can use that. Ping pong, however, because it moves at a constant rate, is good for when we animate this. So essentially, when we get to it, the enemy is going to have a walk cycle, switch frames at a constant rate. It has a specific frame rate. Now, with sine wave, you'll kind of slow down. You'll slow down when it gets to the left and when it gets to the right. And it looks very strange when the character's feet are moving faster than the actual character is moving. So it looks like you're kind of sliding along the floor, like you're moonwalking.
Oh, right, okay.
So it'd be good to have a kind of linear thing. Now, that being said, you can do something like change the speed of the animation depending on the speed of the character. You can do that. But that's a bit tricky, and I don't want to get into it. There are other things, like you could essentially, if you can increase the exponent of that sine wave and use something like a Gaussian curve, you could do something like that as well. But yeah, essentially, it's just because animations look weird if we don't use it. So.
Yeah, Chris said with math.sign, they kind of moonwalk. Yeah. Essentially.
Yeah, and Alex got a good point here. So sine is in sine wave, smooth. Ping pong is in jolly. Ping top, ping bottom. That's essentially it. Yeah, that's the difference between the two. So what we're going to do essentially is emulate the same script here. So I'm going to rob these variables. Okay, I'm going to steal these and put them in here. So we have an original position, and I'm going to set that original position to the position of this thing on start. So when the game starts, we're just going to say the original position, variable called original position, equals transform dot position. So this transforms position. That's what we're going to do on startup. So we have a reference for later on. And if we look at how this is doing it, we're doing transform dot blah equals that. Now I'll tell you what. Let's do the sine wave thing. I'll show you what it would look like, and then I'll show you ping pong. It won't look too bad because this is unanimated, but when it goes onto animation, it'll look quite strange. I don't know. I'll show you. It'll be good.
It'll be good to see.
Yeah, so I'm gonna change this from vector 3 dot up to vector 3 dot left because we want to go right, up and down. Okay. Time dot time times by frequency times by magnitude. So this essentially is this script. It's the diamond bobbing script, but we have changed it slightly. So what I'm going to do is I'm going to go to this enemy. I'm going to open the prefab, and I am going to slap this on, and hopefully, has it compiled? Yes, it has. Great. So if we go back, and now, actually, I think. Oh, did I save that? I don't think I saved it. Have I got the right script on there? I was expecting to see public variables pop up there, but
interesting.
Interesting. Let's go back. Let's remove that and then pop that on there, and then I've got public variables here.
Yeah.
How strange. I'm not sure. We could force it. Let's see if we can force it with serialized field. Just ignore this bit. I just want to make sure that it is not my code that is breaking here. How strange. That is very strange. I've never seen that before, but yeah. Anyways, we just ignore those two serialized fields. If you don't know what this does, this thing here, if something doesn't pop up in the inspector, like this, it's popping up in the inspector, right? If it doesn't pop up and you're like, that's a bit strange, why isn't it popping up? Basically what you can do is you can put this before it, and it's kind of saying to Unity, no, I want to show these things
do that
in the
now.
inspector. Yeah, so you can do that. There is also system.serializable, but serialized field basically tells Unity that this thing should definitely 100% absolutely show up in the inspector, and Unity will do its best to show up in the inspector. So you
try your best, Unity. Yeah, try your best.
You're forcing it to do that. So essentially, this is this script.
Chris, hey, you respect my authority.
Nice. Respect my authority. Yeah. So,
oh gosh.
So now we in the enemy prefab we've got a script called enemy movement, and as you know, as the script kind of I've told you about, it's going to move it left and right. So let's see if this does in fact move the character left and right. Let's hope. Fingers crossed. I mean, it's moving it quite a lot.
It's flying as well, technically.
You can kind of see, you know, it looks a bit odd. You know, but we could change.
It's too like smooth. I know what you mean. It's too like, it's like you've got a slide and you're just going like that. Classic early.
But yeah, you know, you could imagine if we swapped the sprite thing, it would start to look a little bit more like this kind of thing. You know, if we had something like this, it might look a little bit better. But essentially, the smooth movement, we want to get rid of that smooth movement. So we could, for example, manually do this, but there is a little function called mathf.pingpong that I want to show you. So partially because I'm trying to, throughout this series, I'm trying to rope in as little, as much little functions like ping pong and sine that you can use. I mean, some of the coolest game mechanics I've ever seen have been built with these little functions. It's crazy. That's one of the things about games development I love, is that you can take something like mathf.sim.
You don't have to learn you have to know a lot, but you can use like simple functions and it makes your game just look good.
Yeah, and there's loads of features out there that use sign and stuff. So, for example, the whole bobbing thing, you see, I've seen in games on games where boats are floating in water and stuff. That sine wave, you can apply a sine wave to a kind of long chain of, essentially a kind of cylinder, and that has bones in it, and you've got a snake kind of slithering. It's incredible what these little functions allow you to do. So I'm just trying to wheel out as much as possible. So I guess what we'll do is we'll have a look at what mathf.pingpong is. So ping pong, as you can see here, it takes t and it takes length. So as it says, ping pong returns a value that will increment and decrement between the values 0 and length. Okay, so we put in our time here. So you see we've got time.time times frequency here. We put that as the first parameter, and then we put the length in here. So if I do ping pong length, call it that, I guess. And what this will do is it will return a number. Okay, just like mathf.sign returns a number, but we need to translate that into an actual movement, along an axis. So we essentially do the same thing. We do original position plus vector 3 times by this. So it's the same code. We're just swapping out this for mathf.pingpong. And then finally, we can change this magnitude, or maybe let's call it speed, and do transform.position, transform.position, and I'll explain this in a bit more detail in a second. But so we've got frequency, we've got magnitude. Let's change these to speed, and let's change this one to, what is it, ping-pong length. Okay. So yeah, we have transform.position, so the current position equals the original position that we saved at the start, plus left, so the arrow pointing kind of that way, times by this ping pong thing. And ping pong is just going to be a value going from 0 to 1 or 0 to 5 or whatever else. That's just going to go back and forth. But I'll show you what this does. Hopefully, if it works. And fingers crossed. You never know with these things. It'll just make you look silly.
Coding always makes me look silly.
Yeah.
It always finds a way to just break on you at the worst possible moment.
Yeah.
Bye.
I mean, that's quite a big distance. But you see, if I change this number from 1 to 0.5, you can see that this is a shorter distance. So this number here controls the distance they move, and this speed obviously changes the speed. So I can do 10 or 1, and as you can see, it's kind of, because it's multiplied, you have to play around with these numbers to get what you kind of want. So what I would do is, we know that it kind of goes back to the original position here. I realized I was just pointing at my screen, and it always returns to its original position here, right, and goes left and then comes back. So what we can do, right, is we can line this up with the right edge here where we want it to go, press play, and then what we could do is just fiddle around with these numbers until we get it kind of to what we want. So that's 1 and 3. Let's try 1 and 4. That's about right. I think we just need to whack it to 3.5.
Yeah,
I
that's
think
better.
that's okay. So we've got 1 and 3.5. Now remember, when you change these values in play mode, it'll revert when we look at these numbers here on the right. When I unpress this, they go back to 2 and 3. So what was it? It was 1 and 3.5, wasn't it? So we've got that. So we can go back, and now our enemy should go left and right. So that's all ping pong does. Is it does the same thing as sign. It just does it.
We might want to move it down a little.
Yeah, that's true. Actually,
It's slightly floating in the air.
Let's pop them there.
Like
that, right? I think that the hammer, unfortunately, kind of. Let's go there. I mean, it's fine.
It's like fine. A little ghost.
Yeah, it's fine. It's all good. It's all good. So there we go. We have our little character moving, and now we could imagine this kind of flipping, like kind of like this, right? Because there's a big space on the right, it does look kind of strange when we flip the X. as you can see, there's quite a big turn, but that's okay. We can solve that at a later point. And well, I just want to show you the kind of basics of this kind of stuff. So we have our character moving. Yippee! I mean, we could automatically do this kind of stuff where we detect if the character is moving left or if the character is moving right, and if they are, then we can do flip X, kind of like what we did with the character. Right. So with the character, do you remember we did? I'll actually show you this. We had, where is it? If we're holding down D, then flip the X. So make it go that way. If, however, we are holding A, or left or right, whatever, then flip it the other way. Now we want to do this with this enemy, but we want to do it automatically. So we have to kind of figure out if the character is moving left or right at this point in time. So how do we do that? That's a very good question.
How do we do that, Ben?
How do we do that, Ben? So if we had a rigid body, we could look at the velocity. We could look at essentially its speed. We could say, if you're moving left quite fast, then you're moving left. If you're moving right quite fast, well, obviously you're moving right. The problem is we don't have a rigid body on this. So how do we do this? Well, what we could do is save its position, save the character's position every frame, okay, and then look at its new position and the old position that we saved, and check if that new position is to the left or to the right of the old position, if that makes sense. Does that make sense?
Kind of.
Okay.
I think I was following that.
Yeah. So every frame, every update, we save the character's position. Okay. So I'll show you in the edit. Okay. So say our enemy is moving left and right like this. So we stop at this frame here, let's say, and then we go, okay, what was the last frame? The last frame, the enemy was here. So that's where it was last frame, and it's now here. Based on that, we know that this thing right here is to the left of this thing, so it must be moving left. If that makes sense.
Yes, that makes sense.
That's what we're doing. That's what we're going to do. So that's quite easy to do. We just need to make another vector 3, and we'll call it maybe old position. This kind of stuff is used quite a lot as well sometimes. But what we're going to do is at the end of this, we're going to say old position equals transform.position. I think I might be getting the order wrong there, but transform.position equals old position, and then here we can do the flip stuff. So we can say if old position, we've got a question. If position equals 1 pixel right from last flip, this right, if not already flipped. Yeah, so essentially we're just looking at the old. So every frame we're saving the old position and updating it, and then the next frame we can kind of look at the kind of shadow, the ghost of where that once was, and and kind of look at that. Because we're going so fast, if we have any artifacts towards the left or right, it shouldn't matter too much, but we'll give this a go and see what is happening. So we can say if old position.x, so this is the old position. We can say if transform.position.x is less than the old position. So this is saying if the new character is left of the old character, then this must be moving right. Must be moving left. Must be moving left. Do an else if transform position. Well, we could do an else, but I want to be. I don't know. The only other option is that the transform.position.x is the same as the old position.x, and that's kind of rare. But anyway, must be moving right. So now we can do our flip stuff here. So every frame, save the old position or the new frame. So that's all we're doing. Is we're just saving the old position, right? And then we're saying if we're moving left, if we're moving right. That's it. That's all we're doing. Okay. You could do this another way where you could subtract the two and then compute the vector based on that. So you can subtract the old position off the new position, and that would give you a left or right kind of vector. I think Danny has just disappeared. I'm not sure what that's about. Welcome to the Ben Show. Yeah. So anyways, yeah, we could, I'm sure Danny will be back soon, so not to worry. But yeah, we could be moving left using this. So we will do something like get component. We could essentially steal this kind of thing from here, get component sprite renderer, flip equals false, all this kind of stuff. And we could change this to false here and then true in the other one. Right. So this all makes sense. So let's go here and let's try this out. Let's try this kind of stuff here. So I'm going to click here and save, and then save project. And then I am going to press play. And let's see what happens to this character. Nothing. Brilliant. Right, I'm just going to save this and we'll get back to what is going on here. Let's go to the script. We have if transform.position.x is less than old position.x. And I might be getting this wrong. Flip x.true. Else if transform.position.x more than old position.x, then flip that to true. And then we're saving the thing for here. Now, I might be getting the order of this wrong, actually. But we shall see. We've got transform equals this, and then old position equals that. Cool. And yes, I think in theory that should work. Should work. Danny's Wi-Fi just died, according to Chris. I can't highlight his comment because I don't have access to the thingy-majig. Oh no, Danny's Wi-Fi just died. So yeah, welcome to the Ben Show. And today we're going to look at blah, blah, blah. Yeah, so we'll carry on, and hopefully Danny's Wi-Fi will get well soon. He's hoping. So let's just click play, and yeah, nothing is happening here now. I can't imagine why this is happening, but I don't want to focus too much on it. So it's kind of bugging me as to why this is breaking, but who knows? I'll tell you what. Let's debug this, right? Oh no! let's. I'm going to debug.log the old position, right, and just make sure that this thing is actually changing. So we should see in the console a bunch of different messages showing the old position, and it's okay. This kind of stuff happens in games development, you know. Yeah, this is changing, as you can see. We always run across like some kind of error. Welcome to the Ben Show. Hello, I'm your host, Ben. Yeah. So I'm going to do that, and then I'm going to show transform.position alongside it. Let's do plus and do that. I just want to make sure that these two are actually different, you know, and that we actually can, you know, see the difference between these two things. So these two things should always be different. So if I just pause it here, if I pause that there, as you can see, they seem to be exactly the same. So that's probably what the issue is. So we can change that, I guess. If I can't get it done, that's okay. We'll move on to animation. But it's just such a minor thing. Let's try move this up here. Mention Phil. Yeah.
Oh my gosh.
Oh, hello, Danny. Well, welcome to the
I'm currently using a personal. I'm using a personal hotspot. Okay. My Wi-Fi was perfectly fine. But it just was like, nope. I went downstairs and looked at the box, and it was all blue. So that's fun.
Oh dear.
Not sure what's happening.
Yeah. Well, welcome to the Ben Show. We're struggling to get the sprites flipping. So.
Oh gosh. Oh no.
I don't know what's going on with it, but I think I'm going to move on to the animation. I think because I in my head this seems to be working. The code should work, I guess, but I just can't think of the solution at this point. But it might be the case that we may need to flip this like this. see this, but I don't think it's going to execute any of this code because I think they're exactly the same values for some reason. Let's try it and see what happens. No, we get one flip, and that is it. Okay.
Oh, no.
Okay, I'm going to move on from this, but we shall come back to this maybe at a later episode when I come off the stream and figure out what is going on here. How strange. It's probably me just being silly. I've probably done something. But it's okay.
I think this episode's cursed.
Yeah. The cursed episode, yeah.
The cursed episode. Episode 6.
Episode 6.
Just cursed.
The number itself, yeah. So so let's get on to animation. So it's not a big deal if we can't get this flipping. But that's okay. That's just me and my bad scripting. So let's actually get on to some animation instead. So let's go back to our, what was it? Our enemy prefab, wasn't it? It was our enemy prefab. So the thing is now is when we're playing this, our character is just kind of moving left or right, and it's just a static image. Is there a way we could make it, look like it's walking or something? Well, we can do that. And the enemies still look a bit weird. They're sliding on the floor. Can we give it a little walk animation so it's a little bit more natural? Well, we need to look at animation, and animation in Unity is an interesting one. I mean, I'm not an animator, so if something goes wrong during this, then that's my excuse. So I think before we actually get into how to do animation, we need to explain two main things in animation, two concepts. So the first is something called an animator. And what this is it's the component that's attached to an object that kind of actually animates the character.
Yeah, it's the thing that we were talking about this. It's kind of like the puppet master, as we kind of called it. It controls everything. It basically, yeah, it controls all the animations, and it controls, it's a puppet master.
Yeah. So the animator, yeah, all it does is it sits on an object, and it's the thing that actually animates the character. The other thing is an animation, right? The instruction, all it is really is it's the instruction of how the animator should actually animate the character. It's the instructions of what the animator should do. And Phil has said, do a debug print in your if-else cases to make sure they're being called. I was tempted to do that, and I might go and do it. So, but Danny, can you think of an analogy for
animation?
The whole animation thing. I'll just very quickly try this. So let's try this.
I think maybe the animation is the instructions.
Yeah.
So it's so if we okay, good one would be, so if we imagine the animator as like a pianist, and the instructions, the animation is the piece of sheet music that the animator reads from.
Yeah.
I think that's a simple enough, a clear enough kind of analogy.
Yeah.
When it makes sense. It's the instructions which the animator uses.
What's wrong? I think we need to do that. Phil had the right idea. Let's give it a go.
Let's see. Proper ghost, yeah, we can do it.
Hey, this is why I love having Phil in the streams. Yes.
But isn't it the wrong way around?
It is, yeah. But that's okay. We can do true, and we can do false. Yippee, there we go. So now, what was happening basically?
Woo left, woo right.
I was setting the position to the position that would be on the next frame. So yeah, I was being silly basically. So now we have it in the correct order. We're saving the old position, then we're setting the new one, which at this point should be changed. So now we should have a little character flipping. So Big thanks to Phil for prompting me to go do it. So now we should have something flipping now. But yeah, what Danny was saying is a really good way of thinking about it. You can think of the animator as the pianist who actually carries out the animation, and the animation itself is like the sheet music. It's the instructions to play the music. If that kind of makes sense. So yeah, regarding animation, there's many ways to kind of do it. There's more complex animation, which we'll get onto hopefully in this episode. If not, we can kind of introduce you to the animator and then cover it, because it is quite a complex thing, and building an entire animation state for a character, I think, and I'm tempted to just do it in the next episode because it's quite a big topic, but we can at least today show you the stuff behind it. I think that's probably a good plan. But initially, yeah, let's just show you how to just get a walk cycle working on an enemy. So it's fairly straightforward. All you do is, well, we've already split the sprite into separate, like the animation sprites itself. So if I go to the human here, you can see that there is actually all of these sprites here. And if I run through these, I don't know if you can see on the right there. Oh God, no. You can see it's a little walk cycle. So what we want to do is we want to turn this into an animation. We want to say, set the character to this, and then 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 loop it, basically. So how do we do that? Well, in Unity, it's actually quite easy. It never used to be this easy. It was horrendous, absolutely horrendous. So I'm going to click on the enemy here, okay, and I'm going to open the prefab. Hopefully I can do it with the prefab. And I'm going to come up here to the window thing, and I'm going to go out of all these ones here. You can probably see one is animation. Now there's animation, animator, animator parameter. The one we want for right now is animation. We're going to talk about this in a bit, but animation is the one we want. So that's popped up on my other screen, so I'll bring it over here. So it says to begin animating enemy, create an animator and an animation clip. So let's do that. So we press create, and as you can see, it just wants you to put it somewhere.
You get to name your animation.
Yeah. So I'm going to make a new folder just to make everything nice and tidy. Call it animations. And I'm going to pop it in here, and I'm going to call it maybe enemy run anim. Awesome. So now we have an animation in our game. Okay. Now this window is in the way, so I'll put this one here. I don't know, it's not really a good view, but if I zoom in on the character, you can probably see what's going on there. So we have our little character here. Now we have the animation window here. Now, don't worry if this is a little complicated. I mean, if it looks like Jesus, that's weird.
What's going on here, Ben?
I mean, don't worry. I mean, I've been doing Unity for donkey's years, and this stuff still is like, I have no idea.
I just thought when I do animations, I just literally follow a process, and then I do the same thing again and again. Yeah. So I just like, I only know one way.
Yeah. The cool thing is it works a lot like other animation systems. So what you can do is you can say, I want to change the position over time. So you can set a keyframe here to, this or something, and then you can say, over here, I want another keyframe. I think you can add a keyframe here, right? But you can change this position to maybe -1 or something, and then it will animate the character. So this is your timeline. So this is just stepping through the frames. So you can see the frame number here. This is 3. This is frame 0, frame 1, frame 2, frame 3, and it's moving between this keyframe here and this keyframe here. So we've got over here the value is minus 2.6, 256, and then on here we've got -1, and it's just smoothly changing between those. So that's how we can do manual animation, but we don't want to do that. We want to switch the sprites automatically. So how do we do that? Well, let's open up. See these sprites here down the bottom. We can hold shift, okay, and click, and this will allow us to select many things, right? So we're going to select them all of these things, not this one here, but just these things that are highlighted, And all we have to do is just drag them in to there. Okay. And now we have our animation. As you can see, we've got a little character.
That's so cute.
I mean, it's a bit fast, but
oh my God.
it's a very fast walk cycle. But as you can see, if I flick through this slowly, it's changing the sprite. Okay, and that's how we can make a walk cycle. So we just drag it onto there and it works. Now, how do we slow this down? Because this looks ridiculous. Yeah, that's way too fast. So how do we how do we slow this down? There's a few ways to slow it down. The easiest is to just grab this. You see this I don't know what it's called, like the line here, and it's got a little, my cursor changes to a left-right thing. So you can actually drag this out to make the animation longer, and that way make it slower, So we can do that. Also, I should really tell you about these controls. So this is play. You can click on this to play. You can click it again to pause. There's here, you can go to the other keyframes and stuff like that. But really, just figure this out for yourself, really. I mean, it's just a case of this is the frame number. This is
it's not going to break your game if you press a load of buttons.
Yeah, exactly. I don't want to get too much into how to use this animation window because, like I said, I mean, that's a completely different thing. But this record button is really useful. You can actually record your character here and then move a few frames in the future and change loads of different properties about it. Maybe the scale, the rotation, the position, and it will automatically detect the movement. I might even, if we have time after this, I might even show you how to work that. But it's a really cool little feature. But yeah, we have our little character doing this. The other way to slow it down is to leave it here, okay? And you see these three dots up here? We can click on these and do set sample rate. So we can change this to 24 frames a second, for example. And it hasn't made much difference, but as you can see, it is slightly slower. But I'm going to change this back to 60. I'm going to select all of these and kind of drag them out to about 30. Maybe let's say 20. I think that's about right. That looks like he's running. So that's our animation. We've set it. It's great. Everything's all good in the hood. So we can click on this thing, and as you can see, we have an animator here. Now this was added automatically for us when we clicked on the animation window, but you can do this manually as well. So you can do it this way as well. Now, hopefully, when we go back to the scene, we should have an animator on here, and if we click play, hopefully,
fingers crossed.
Yeah, as you can see, he's moving around. Let me zoom in so you can see that. But now it's starting to look a little bit more like a game. We have our little character running back and forth, and by the way, the reason he's running back and forth is because of this animator. Okay, if I turn this off, you can see he's sliding. If I turn it on, he's just doing this. So all this animator is doing is it's made a controller for us. I'll get into what that is in a bit, and it has made a little animation. We've made this animation. If I double click this animation, oh, it won't let me preview it. But basically, yeah, if you can open up this animation here on the right, and you can see what is going on with it. So that's how you edit animations. And as you can see, we've got a little enemy moving back and forth. Now, because this enemy is a prefab, okay, we can actually move this enemy into, we can make another one, right? We could go here and whack in another enemy here, okay, for this little section here. And we could click play. And now we should have two enemies moving around, So now we have two enemies, and we can try avoid them, I mean, we have to fix the jumping, I know. But,
I like being able to fly.
Just fly. Maybe that'll be the game. We'll just pigs can fly.
Flying pigs, yeah. Pigs do fly.
Not a very hard game. But if I touch an enemy, I spawn back, as you can see here. Here you go. I'll show you an example. So let's pop down here. Oh, I die because I hit a pig. Sorry, an enemy. And now we're all good. Now the enemies look pretty cool. They've got a little walk cycle going on, pretty nifty, and we've talked about that. But what about the player? Okay, because we need to animate the player. Can we get the player doing a similar thing? Well, of course we can. There is a run cycle for the player. However, and this is the door, this circle. We'll have to change that at some point too. But the thing with the player's animation is it's a bit different to the enemy's one. The enemies, in this case, are just going to run back and forth and just run forever. That's all they're going to do is play one animation. We've looked at applying one animation to something, okay? But the player is different. The player could be running, could be jumping, could be stood still. So there's many different animations in there. The player has a standing animation. The player has a running animation, okay? And we need to switch between those animations on the fly. Now that's a harder problem because the enemies were just doing one thing over and over again. But the player has to kind of change from one animation to the next, depending on their state in the game. So if they're jumping, we need to say, hey, play the jump animation. If they're running, we have to say, hey, play the running animation.
So we kind of have to go through the different states of the what the player is doing. So you could, as you said, going through a run, being idle, jumping, you name it. It's not as like definitive as just going right, left. That is the only thing that the enemy is doing, whereas the player, does loads of different things at any point.
Yeah, and I think in the interest of time, we will probably show you how this is done today, and then next time we will kind of, at the beginning, we'll have a look at actually building this, because animation is quite an important thing in games, and it's also quite a complicated thing to actually get set up. But yeah, we'll show you how to do this now. So how do you do that? Well, there is something in Unity built exactly for this purpose, and it's to do with, do you remember this animator component? Essentially, it's the same thing. We have to make one for the character because we will want to eventually animate this character. So we have to add a animator. So we type in animator, as we can see, or I think you can do it this way as well. You can go to animation, animator. Okay. And I think you can do it this way. I don't think you can. I'm wrong, but that's okay. We can click on animator, and now we have a animator here. Okay. Now the animator, as I said, it's the thing that controls the animation for an object. Okay. So in the case of the enemy, it was the thing actually moving the changing the sprites, I should say. Essentially, we want the same thing for the player. So we're gonna click on this, and I always forget how to open up this stuff. I again, you can probably tell I don't do a lot of animation stuff. I just leave it to other people and just kind of, it's so confusing. But yeah, I'm going to open the animator window, and hopefully I can make a thing. Nope. Yeah. Oh no. Okay. So what you got to do then is you've got to go to assets. We'll make a new folder. Let's go into the animations folder and maybe create a new, or maybe I should make a folder. Okay, I'll make a folder and I'll call this folders. Let's make a new animation controller. Okay. Now there's quite a lot of terms to unpack here, like animator, animation, animator controller, and you're probably thinking, oh, well, isn't an animator controller the same thing as an animator? I don't understand. An animator controller, as Danny said before, is like the puppet master, right? An animator is what you give it a controller and it goes, cool, I know how to animate that particular thing. Don't worry, this stuff is confusing, but basically if you have an animator, it has to have an animator controller. Yeah, so we're going to call this maybe animator controller. Yeah, something. As you can see, one of these was already made for the enemy automatically for us. As you can see, it says enemy.controller. Okay, the enemy has one of these too. It's essentially when you create an animator, you have to create a controller for the animator, which is kind of telling it how to control the animations.
Yeah, what to do basically.
Yeah, and it all comes down to this. When we get into this, you'll kind of understand what is going on. Okay. So we have our animator on the character. I'm going to drag this into here. Okay, so now our animator has this controller. So this thing here is for the character. So we can click on this and we can edit it in the animator window. So do you remember, if I close this, I go to window, I go to animation, and I click animator. Okay, and then you can drag this tab wherever you want. I'm going to put it here. So yeah, there's Adobe Reader. Thanks for joining us. So if you've ever come across the thing, something called finite state machines, this is a very similar thing.
It's basically you have all the different. So within the animated controller, you have like currently there's nothing, but we'll be adding like the character being idle or like standing still and running, then attacking. So basically, we're just choosing we'll choose which state we want the character our character to be in, and we'll like kind of create arrows and create kind of conditions and for going into each I think I was trying to my next word was going to be different, so I kind of combine those words. So each different kind of state so it's like a flow chart. It's just like, okay, do I want am I hungry? Yes, go get food. Am I hungry? No, then do nothing.
So it's quite a straightforward thing to get your head around. So all we have to do is think of the possible states, the possible animations that are going to play on the player. So we're going to have idling, so just standing still, running, because we're going to move, and we're probably going to have jumping as well. So that's three possible states that the player can be in. And what we do is we make these states in here. So if I right click here, it says create state. So I can create a new state, and I can call this state up here and call this maybe standing. So this is a state called standing. We can make a new state here and call it, running. Okay. And we could have another state. Let's call it jumping.
Right? Jumping / flying in our case.
Yes, flying. So yeah, if we position these states here, so we have three possible states the player can be in. It can be standing, they can be running, or they can be jumping. So we've defined that, but what we need to also define is, can we go from standing to running? Can we go from standing to jumping? Or do we have to go running to jumping and stuff like that? So we need to, if you think about it, it would probably make a lot more sense in this example if I had, and I'm just going to create an estate for just to show you this. But if I had a state called attack, like if the player was attacking and we only wanted the player to do ground-based attacks, then there's no possible way they can go from jumping to the attack animation, because it makes no sense. They can't do a ground attack in the air, so there's no way they can go from jumping to attack, but they can go from running to attack, if that makes sense, or if they're standing to an attack. Hopefully that makes a little more sense. But essentially what we're defining here, what we need to define, is how we can go from one state to another. So for example, if we can go from standing to running, which we can make a transition here, and we can say, so we can right click on this and do make transition, and we can say that you can go from standing to running. Okay, so that's what that arrow is saying. It's saying you can go from standing to running. You can go from the standing animation to the running animation. You could say the same backwards as well. You could say you can go from the running animation to the standing animation. So now we have a two-way kind of deal going on here. You can go from standing to running, and you can go from running to standing. And it might seem a bit pedantic, and the reason we're doing this is because Unity needs to know this information. If we say, "Hey, jump," it needs to go, "Oh, I can't play the jumping animation because I can't possibly do that. I'm in another state." So let's think about other stuff we can do. We can go from running to the jumping animation. We'd like that, we can run and jump at the same time. And we can go from jumping to running as well. So we're going to do a two-way relationship there. And can we go from standing to jumping? Well, yes, we can.
Yeah.
And we can go from jumping to standing as well. So we can do all this. So we've got a little triangle sort of going on here. We can go from standing to running. We can go from running to jumping. We can go from jumping to standing. So, and or vice versa as well. You can go through all of these different states, which is kind of perfect, right? This entry thing basically is like the start position.
The start, yeah.
Yeah. So that's all that's going on here, and we'll talk about this in more detail next time, because we'll probably actually show you how to like attach animations here. Spoiler, it's here. This motion thing here. You can
Spoiler.
You can pop in your animation here, and it will associate that animation with this thing. So if you're in the jumping state, you can put in your jump animation. If you're in the running state, you can put in your running animation. And what we'll do next time is, we can find and make the idle animation, make the running animation, make the jumping animation for the character, and then pop them in here and see what happens. So yeah, this thing here, and just to give you some technical detail here, because we are probably going to touch on it later on, but these are called states. Okay, these things are called states because
they are your state, what you're currently are doing, what you're.
Yeah, exactly. So that's your state. These things here, these lines, are called transitions. Okay, so you can see it up here. These are called transitions because you're going from one state to another. You're transitioning from standing to running. That's why they're called transitions. Okay.
A lot of this it's very self-explanatory in the way it how it works and the way it's all labeled.
Yeah, and I think talking about like the jargon and stuff, we're probably next time I'll be like, oh, okay, we're going to create a transition, blah blah blah, and just what is kind of know what these words are. Now, we can also have conditions, right? So a transition can have a condition. Okay, we can say, for example, if the player's speed is more than a certain value, then set running to true, or make that transition into the running thing. At the moment, we're just saying, oh yeah, you can go from standing to running, and oh yeah, okay, you can go from running to jumping. But what we can do is we can say how you go from standing to running. You can say you go from standing to running if this transition has a condition. So you can say, for example, here you can add a new one, and I mean it's just saying that at the moment.
Does not exist.
But you can essentially say it goes from standing to running based on a condition. So in our example, we could go from standing to jumping if a variable called jump is true, and if it's false, we can go back from jumping to standing. That's the idea. And I think the last thing I want to touch on, and before we end and go and wait for the next one, is parameters. So do you remember me saying, oh, you can do it based on a variable, like if jumping equals true, go to this state. That's what these parameters are. So you see this little button here called parameters. We can add variables. So we can say float, int, bool. So we could make, for example, a bool and call it jumping. Okay, and we can set it to true or false. Okay. And we can make another one called running. And now what we can do, these are essentially like variables, and we can click on one of these transitions, and over here we can say, okay, because this is going from standing to running, we can say if only go from standing to running if running is true. Okay, so if running turns to true, I want you to go from standing to running. Okay, we can do the opposite. We can say if we're in the running state and if running turns to false, okay, so we're saying we only go back through this way if running is false. We only go this way if running is true. So what you can do is you can actually, I think you can run this and test it. So let's try this. So No, ignore me. That's okay. But yeah, we can.
We'll show you how it works next week, basically.
Yeah. But I just wanted to go through these features because that's when we talk about next week. This will be quite crucial.
Yeah, we just want you to understand kind of like the terms we're using, just so that next week we can just run in and do it, basically.
Yeah. Essentially, yeah, what we're going to do is we're going to actually turn this into something that works. We've described what states are, these things. We've described what transitions are, these things. And we've kind of talked about conditions. Conditions might be a little bit confusing still, but that's okay. We have these variables here, and we can say that we can go from this one to this one when running is true, and we can go from this one to this one when running is false. So that will form the basis of our animation system for the character. But the actual details of it and actually getting everything working, I imagine that's what we're going to probably spend the next session, the next first half of that, spending just on that, because it's quite a complicated thing to get all this working, and if it is complex, I understand it's quite hard to wrap your head around. I mean, to be honest, like I said, I've been doing this years, and this stuff is still kind of, I'm like, oh, I just, so don't worry about it. It'll all be okay.
Okay, so I'm guessing we're ending the episode there and focusing on animation more next week. So I want to thank everyone for joining us today, and I'm very sorry that my Wi-Fi decided to have a meltdown and just suddenly stop working. Oh well, we're back. So we'll hope to see you next week. We'll say our goodbyes. Goodbye, everyone.